Hey everyone, today we're gonna talk about NeuroAI and neuromorphic hardware synapses on the chip. And my first question, can AI learn better by mimicking how the human brain learns from examples and prior experiences? So, Google DeepMind's Dileep George said NeuroAI is an alternative to the current endless scaling of systems to improve them. The most complex computer in the world is the human brain. This slab of fat, water, protein, carb, salts, and nerves is more complex than any AI system to date. Could understanding how it works be the key to unlocking the next generation of AI? Experts at the World AI Council Festival seem to think so. The concept they call NeuroAI refers to the way our brains learn from examples and prior experiences, and this could be more beneficial to teaching AI tasks than merely training it with ever increasing increments of data. Tristan Stauber, a research leader from Ruhr Universität Bochum, cited the example of baby horses, how they can walk mere hours after they are born. Imagine having a kind of neuromorphic hardware that could follow for a neural network to be integrated directly onto a device, mimicking the potential action of the brain. Stopper explained, you have asynchronous computation. It's not like a neural network where for every time step, every clock step, you compute the activity of all neurons at the same time, but you basically integrate information and only when it reached a certain threshold, it sends an electric pulse further. And that means that when there is nothing interesting, there is hardly any energy use. He proposed such systems could be used to power robots more akin to those seen in science fiction, allowing for AI to potentially gain a better understanding of the work around them, something systems currently lack in great detail. Dileep George, the director of research at Google DeepMind, proposed NeuroAI as an alternative method for endlessly scaling system in a bid to improve them. George likened the concept of early flight. Most astronautics' effort in the early 20s and 30s focused on balloons that endlessly scaled. But following 1937's Hindenburg disaster, airplanes became the focus. The DeepMind research director said NeuroAI could be the AI equivalent of the airplane, and then researchers shouldn't be satisfied with solely scaling systems. Today's large language models are trained on mostly language tokens. According to George, that is not enough, as he advocated for grounding models with mental simulation as a means to teach them how to perform tasks. Language is just a way to control mental simulations, he said, adding that even if humans didn't have language, their experiences would be enough to provide them with information to make actions. Sentences alone don't make sense. Language can fake it just like balloons can fly. Right now, let's go jump in the next topic about synapses on a chip. Achieving brain-like AI is a long way off and requires a lot more research. There have been some breakthroughs like IBM's Northpole chips that are means to mimic how the human brain processes information. One breakthrough showcases in Cannes was the idea of synapse circuits. Professor Giacomo Indivari from the University of Zurich and ETH Zurich showcased the idea of recreating brain synapse circuits in chips. Chips. Okay, chips. Okay. Indivari explains that these simple circuits can be recreated with transistors and placed on a chip to create neuromorphic processors. They are designed to use little power, are lower latency, and more compact. In the various set, drones are already using them today. However, if you want to scale up such processors, this is where it gets hard. Indivari explains that to scale a neuromorphic processor, you will need a larger area on a chip. Such systems are low accuracy. What he said, I would not use the chips to control my bank account, but I would put it in a Rosie the robot. It is possible to build synapse-like structures on small-scale chips today. With more research, the mysteries of the brain could make what's improbable of AI finally a reality. So, what is NeuroAI? We are wrapping with our topic with chips and chicks, crispy chips. So NeuroAI is about making AI learn stuff like how our brains learn from things we see or do and from what has happened to us before. It's like teaching AI to learn in a more human-like way instead of just feeding it more and more data. What is the human brain? The human brain is super complex and very awesome. It can do things that no computer can do right now. People are looking at the brain to make it smarter and more like VR. So we talked about baby horse example to summarize it. Just like baby horse, we walk just a few hours after they're born. Imagine if we could make robots or AI that learn super fast because they work more like our brains. Neuromorphic hardware. This is a fancy term for tech that acts like brain cells on a device using less power and only working when it needs to. Could make robots way cooler and really smarter. From balloons to planes, just like we moved from using balloons to using airplanes for flying, NeuroAI is about finding a better way to improve AI, not just making it bigger and hoping it gets better. So we can make a summary that language is not enough. Today's AI learns a lot from language, but that's not enough. It needs to understand the world like we do, thought experiences, not just only words. Like we need actions, like in reality. And from synapses on a chip perspective, scientists are trying to make chips like the brain for robots and AI that work like the connections in our brains and connections with neurons, etc. This could make AI much smarter, but it's still early days for now. So imagine if your computer or your game console learns things like you do by seeing things happen or by trying things out, not just by reading a textbook. This is what some smart people are trying to do with AI. They're looking at our brains and trying to make AI that can learn in the same cool, complex way. Right now, AI is kind of like a balloon. It can do some stuff, but it's not as amazing as it could be. People want to make AI more like an airplane, which means making it smarter in a way that's more like humans or animals learn and understand the world. They're even making special chips that act like our brain's connections, helping AI to think and react more like us. But in tough to make these chips work really well for everything, so there is still a lot to figure out. So what's all this mean for you, for us? Well, in the future, you might have robots or AI that are much smarter and understand you better. They could learn from what happens around them and be more helpful or fun to hang out with. But we're not quite there yet. Scientists are still figuring out how to make this brainy AI stuff work. Thank you for joining me for today and see you in my next video. Bye!